Okay, today we're going to do a little bit of review on Pythagorean theorem just to make sure that you can follow the directions for some other questions. We just need to review a little bit about how do you find a missing side on a right triangle. And that's what Pythagorean theorem is all about. It was designed to only use with right triangles, but a right triangle has two legs and a hypotenuse. The hypotenuse being that side that's across from the right angle. And so because of that, we need to look at it in terms of any of those three sides could be missing. So for example, on this first one, this is a 40 is a leg and 30 is a leg because legs meet at a right angle. So either one of those could be A or B. So we'll just say the bottom is A and the side is B. Then this one across from the right angle has to be C. So if I fill in Pythagorean theorem, I'll have 40 squared plus 30 squared equals C squared. Now, 40 squared is 1600 and 30 squared is 900. Because it's easy to square it because you just square the 4 and put down the 16 and then you'll have a 0 for each 40. That's an easy way to square. Same thing with the 30. 3 squared is 9 and a 0 for each one. Now that adds up to 2500. So in order to finish solving this, we have to square root 2500. Now, we don't know if that's a perfect square root or not, so first we would just type that in our calculator and see if 2500 has a square root. And it does. It's 50. If it didn't, then because this says simplest radical form, we'd need to tree. Maybe one of these others will need treeing because this one's a perfect square. So looking at this one, the one across from the right angle is 25. So that's our C. So the bottom is A and the side is B. Or if you'd rather switch the A and the B, you can do that because A doesn't have to be on the bottom, which might make this question a little bit easier. A just has to be one of the legs. It doesn't say it has to be the bottom, so you could do the A on the side if you'd like. So x squared plus 3 squared equals 25 squared. Now 3 squared is 3 times 3, which is 9, and 25 squared is 25 times 25, which is 625. So in this problem, I can't add the two together because I have x squared plus 9. So I'll take 9 away. X squared equals 625 minus 9, which is 616. And I don't know that it has a square root, so I'm going to check it on my calculator, and it doesn't have a perfect square root. So that's where, when we decide we want to square root these two, we're going to have to find something that goes into 616 off of our perfect square list. So I'm thinking, just to get started, I'll just try different numbers. Okay. Okay, 4 goes into it 154 times. That's probably the biggest one that can go into it because 154 is divisible by 11. I don't think anything else will do it. So that will be 2 square roots of 154 for the final answer. And then for this one over here, the one across from the right angle is C, so since the two legs, it doesn't matter which one's A or B, I always make the one missing A. And therefore, I have x squared plus 4 squared equals 18 squared. X squared plus 16 equals, let's see what 18 squared is. It's 324. So again, I can't do x squared plus 16 because I don't have both numbers. So I'm going to take 16 away from both sides. And 324 minus 16 is 308. Now I'm pretty sure 308 is not a perfect square. So therefore, since it is not, I have to find something that goes into it. And typically, I would start with numbers that are really, really high, but I really don't know what goes into it, so I just tried 4 because it was an even number to kind of get myself started to see what went into it, and it went 77 times, so that happens to be all I can do. And that makes it 2 square roots of 77. That's what we call the simplest radical form. So that's kind of a review of what. Okay, so let's look at what I have down here at the bottom. I'm going to raise my sheet up so I can move the writing down, I believe. So sometimes you'll be given something like this. Now this one's a little bit vague, but I think the directions are pretty good for what they're asking you to do. It says, for each pair of numbers, find the third whole number such that the 3 numbers form with the Pythagorean triple. And what a Pythagorean triple is 3 numbers that you can plug into Pythagorean theorem, and it will give you the correct value for the 2 sides to match. So when it says find the third whole number, that means to find C, because Pythagorean triples are given in the first number is A, the second number is B, so what would C be? Now, if they didn't give it to you in this direction, they would tell you if you're looking for A, B, or C, or they maybe would show the 3 blanks and they would be in order, but typically they'll say like, find B, for example. But this one says find the third number, and the third number is always C because they're always in order. So 32 squared plus 60 squared equals C squared. So if I just go ahead and type 32 squared plus 60 squared in my calculator and let the calculator do all of this expression at once, I get 4624. Now, I don't know if that has a square root, so I square root that number, and it does. I can square root this very easily on my calculator. It actually has a nice answer of 68. So sometimes they're square rootable. The whole entire number is square rootable and will give you a nice whole number. So let's try that again. If this is A and this is B and I'm looking for C, then 80 squared plus 18 squared equals C squared. Again, I would do the 80 squared plus 18 squared all at one time because you're using your calculator. And then I would try to square root that answer. And the square root of 6724 is 82. So that's much simpler to find C than it is A and B. You saw the A and B answers that we were working with earlier. You had to subtract to find those. These, you just do that one whole side out until you finish it. You're staying with working on that side. So in our next question, it says we have a play-in surface of a football field. It's 300 feet long and 160 feet wide. So let's draw our football field. So it's 300 feet on this side with 160 feet on this side. And the question says, if a player runs from one corner of the field to the opposite corner, which means he runs on this diagonal, how many feet does he run? So here's your right angle and your right triangle. So it's going to be here is your side C again. So that means one of these is A and one of these is B. So in that case, we are looking at 300 squared plus 160 squared equals C squared. Now if I type that all in at one time, 300 squared plus 160 squared comes out to be this really, really large number of 115,600. Then if I square root that, square root answer, I get a really nice number of 340 feet. And so what it ends up telling me is that this is a Pythagorean triple, that I have nice whole numbers that all come out evenly, and that the distance across that diagonal is just a little bit longer than the field. Now in our next one we're going to look at, it says draw a square. So I'm going to draw the square. Each one of these has a right angle. It says draw in the diagonal. So it's to be 12 centimeters. So I'm drawing the diagonal, 12 centimeters. It says what's the perimeter of the square? Well, to find the perimeter, I have to know what at least one side is because all 4 sides are the same. So the thing that's interesting about a square is these two sides are equal. So if this is x, then this is x. So we have x squared plus x squared, because they're both the same, equals 12 squared. 12 has to be your C because it's the hypotenuse of the right triangle. It's across from this right angle. So because it's across from that right angle, I know that's got to be C. The other two have to be the same measurement, so we made them both x. So that's 2x squared, because you got to add like terms, equals 144. Because 12 squared is 144. So first I divide by 2, and x squared equals 144 divided by 2, I believe, is 72. Yep. So the square root of 72 is what I need to find. And it said to express it in simplest radical form. So let me write that perfect square list and go over this a little bit more in detail that we were doing earlier. This is 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 64, 9 times 9, 81, and 10 times 10 is 100. So 72 falls in right here. So something above that line is going to go into 72. So 72 divided by 64 does not go evenly. 72 divided by 49 does not go evenly. 72 divided by 36 goes evenly 2 times. So I just keep dividing. Whoop, that's supposed to be 36. 36 and 2. So the square root of 36 is 6, and the square root of 2 I don't know. So that tells me that that's how many centimeters I needed. Now, normally in a word problem they ask for you to give more of an exact answer as a decimal instead of this, but they wanted me to find the perimeter. So there are 4 sides. 6 square roots of 2 plus 6 square roots of 2 plus 6 square roots of 2 plus 6 square roots of 2. I'm going to add them all together, or I could go 4 times 6 square roots of 2. Okay, so here we are with the 2 different ways. So if I add 6 plus 6 is 12 plus 6 is 18 plus 6 is 24, I would get the same answer as going 6 times 4 is 24 square roots of 2. Because in radicals, you could either add the numbers in front of the radical to see how many square roots of 2 you have, or you can multiply 4 times 6 because you have 4 of the same thing, and that'll tell you have 24 square roots of 2. You never change the inside of a radical in adding because it's how many objects you've got, and you've got square roots of 2. So that would be centimeters. Now, on our next page, we're going to look at, is it a right triangle or not? And so this is going to kind of lead into the second half of our lesson, and that is, what can you use Pythagorean theorem for? So first of all, to see if something is a right triangle, what you want to do is you want to take the problem and plug it in Pythagorean theorem and see, does it check true or not? So if this is A and this is B, and this has to be C because it's across from the right angle, then 11 squared plus 11 squared, does that equal 11 square roots of 3 quantity squared? And so you could just type this in your calculator and work both sides. For example, if I type 11 squared plus 11 squared in my calculator, I get 242. But if I type parentheses 11 square root of 3, I'll have to end the parentheses because it's going to make me put them around the square root of 3 and the whole thing. So I have to end 2 parentheses before I square. I get 363. So they're not equal to each other. So this is not a right triangle. Over here, if I say A is 9 and B is 12 and C is 15, then 9 squared plus 12 squared, does that equal 15 squared? 9 squared plus 12 squared is 225. 15 squared is 225. So this one would be yes, this is a right triangle. Now, when it's not a right triangle, there is a way to tell if it's acute or obtuse from this whole lesson, so that we're going to move our screen up so we can write a couple of rules real quickly for you. So c squared, we're going to turn the problem around just slightly. We're going to look at it from the perspective of c squared is less than a squared plus b squared is acute. And c squared equals a squared plus b squared is a right. And then we're going to look at c squared is greater than a squared plus b squared is obtuse. You can use Pythagorean theorem to denote, whoop, I got my letters wrong in that one. Being a little dyslexic this morning. T-U-S-T. Yeah, okay. So we can look at it in terms of, we can plug the numbers in for A, B, and C and see if it's greater than, less than, or equal to, and that'll tell us which triangle we have. So these are in order, A, B, C, like I was talking about earlier. So if we look at 16 squared, 9 squared plus 11 squared, we don't know which symbol to put between there right now because we need to work the two sides to see if it's greater than, less than, or equal to. So 16 squared comes out 256. And 9 squared plus 11 squared comes out 202. 256 is greater than 202, so that makes this one obtuse. Now, when we look at the next one, 4, 6, and 7, this is A, B, and C. So 4 squared plus 6 squared equals, let me start that over. Always put your c squared first. 4 squared plus 6 squared. Somehow we got to compare that to 7 squared. 7 squared is 49. And 4 squared plus 6 squared comes out 52. That's less than. So when it's less than, it's acute. So in our last example, this is A, this is B, this is C. Remember, you have to write the C down first, squared, and then the A squared plus B squared. We have to turn the problem around a little bit for Pythagorean theorem. We'll put the C first. This is 100, and 6 squared plus 8 squared is also 100 because that's 36 plus 64, and it's equal, so it's a right triangle. So it's just a way of telling what kind of triangle you have. And it's just a little quick, easy check. So here we say we want it to be an acute triangle. Two of its sides measure 33 and 55. What does the third side have to be? But in this problem, when they ask for the third side, that doesn't mean that I'm looking for C, although it could mean that. So let's look at that possibility. 33 squared plus 55 squared. For it to be acute, it has to be less than C squared. So let's see, what would that make it? C, 30 squared, 55 squared. 33 squared plus 55 squared comes out to be 1441. Square root that to find C. And you get C has to be less than 64.1, and we're going to write decimal answers for this. But we don't know that that's what they were looking for. That's just one value that it could be. We also could think about the fact that maybe 55 is the biggest number. And so we could say 55 squared equals A squared plus 33 squared. And not equal to. Still looking for less than. I keep forgetting that. Because we're looking for an acute triangle. So 55 squared is 3025. And 33 squared is 1089. So if we take away that, take away 3025, we get 1936. So let's square root that. The square root of 1936 is 44. That came out exact. So what this is telling me is somewhere between 44 and 64 are all the numbers that can work for either A, B, or C to come out to be an acute triangle. So 44 is less than my side is less than 64.1 are my measurements that it would have to fall between. All right, let's look at our next question. You do this one the same way. Because you're looking at for obtuse, though, you'll do it with a greater than symbol. So let's see how that works. So first, let's do it with, what if that side happens to be, that's missing is really the third side? 60 squared plus 65 squared. Let's see what that'll come out to be for C. 60 squared plus 65 squared. Square root it. I get 88.5 for C. It has to be greater than 88.5 for it to be obtuse. Now let's see what it comes out if we're doing it with, what if one of these two, is A or B, and this 65 happens to be the largest one and happens to be C. So 65 squared is 4225. 60 squared is 36 with two zeros because it's easy to square numbers that end in 0. Whoop, I keep writing equal to marks. Keep forgetting I'm not doing equal to. I'm supposed to be doing greater than. So take away the 3600. Square root it. And that tells me that I get 25. But I should turn that around, and A can be less than 25 because it doesn't make sense to have the variable on the right side. It only makes sense if it's on the left side. So now I can write down my final answer that X can be less than 25 for one side, or X can be greater than 88.5. So in our last question, we have a similar thought. It says a classmate drew a acute triangle with sides 9 and 12. What's the greatest possible for the whole number that's left, for the longest side? So in this particular case, we're looking for acute, and it's telling us it has to be the longest side of the triangle. So that kind of narrows my focus down a little bit, that I'm looking for C squared to be less than 9 squared plus 12 squared. Because it says it has to be acute, it says we're looking at the greatest possible number for it. And we're also looking for, it can be the length of the longest side of the triangle. So that meant it couldn't be that 12 is the longest side, for example. So 81 plus 144, 81 plus 144 comes out to 25. So if I square root that, the longest side has to be just a little bit less than 15, and it will still be acute. When it hits 15, it will no longer be acute. So that's a little different use of Pythagorean theorem than you're used to. So I hope that you can practice that on your worksheet and get good at figuring out what kind of triangle you have.